That's been 15. The group assignment.
Okay, let me get it here. I have been out of electricity most of the day. It just came on probably an hour ago, and I've been trying to get this stuff up and running. Let's see, where am I? Where am I? Are you still there, Macy?
Yep, I'm still here.
I like it how computers remember stuff so well. You have to click on the same thing over and over again. Okay. Well, I see me up there, but I don't need to be up there. Somebody else needs to be up there.
I actually sent the letter in Kelly's Bree's room.
So, when you want to start, are you ready to start, Rusty?
I am.
All right, woohoo!
I was telling. Let's see. Can you hear me?
Yeah.
Yeah, I hear you just fine.
Okay. So I was just telling Macy that about an hour ago our electricity came back on. We've had a pretty big windstorm and lost our electricity today.
Oh, wow.
And I've been trying to get back on. It finally came on about an hour ago. So I am kind of off in the dark. I was literally, but in more ways than one. So.
I didn't.
We didn't even have to use IUCSS, in my understanding. We just used Excel.
Correct.
And there's just equation. And so I just feel like it's really good to really just go over everything. So I don't know.
Has anyone heard anything else from Nelson this week?
I talked to him last night, and he asked me, he told me that he didn't do very well on the exam, and he asked me what I got, and I told him I wasn't comfortable with what I got. I got an 89, and then that was the last I heard from him.
Okay.
And, well, and then I did try to get some information out on him. You know, we were talking about that group project last week or maybe the week before, and we were talking about using M&Ms, the study on the M&Ms. And I asked him, do you even have M&Ms in your country? I sent both of you an email where I forwarded the message that I got back from the instructor. Did you get that?
I've been running so fast I haven't had a chance to look, Rusty.
In essence, what I read, or the email that I sent to her was pretty much what I read to you, Kenny, and what I sent to you, Macy. You suggested that I ask her if she had any ideas, and she said that she liked my idea of putting him with one of us. You know, if we assign him a task chances are it's not going to be done. And I just didn't want that to happen. So she said if we double up, that sounds great, and she was grateful that we were trying to get him included in all of these things. But she and the PA had also been trying to get a hold of him and hadn't much success.
Macy, it looks like you dropped off the call.
Yeah, my computer's trying to get in, and I don't know how to get it back on.
Okay.
I thought the way to get back on, I don't know how to get another request.
Okay. Well, that's probably because I made the group public, so anybody on the internet can join in. Aren't we so excited?
If they want to come to this meeting, they are welcome to come.
All right. Are we ready to hit start on 16?
Yep.
Let me get in there.
I had already hit start, so hopefully it just saved it or something.
Fortunately, it is a save for later.
So number 16,
Yep, 16.
I'm hitting start.
Was she able to find a tutu? You are the best. Thank you. Are you going to give me a refill so we can share? All right.
Right. First two are true.
Oh my goodness.
So
Why are the pies?
Why are the slices different sizes?
Because I want more pie than the next person.
By the number.
So the size of, let's see, the size of each slice is random.
No.
It's determined by the number of categories. Represents a category in the area of each slice represents the proportion of the total occupied by the category. I think that one's it. The second one?
That's what I think.
Me too.
All right, number 4. How are bar charts and Pareto charts related? They are identical. They're constructed from costing a coin. Okay, it's the bottom one, yep. All right.
We conclude that P hat is normally distributed if NP is greater or equal to 10 and N times 1 minus P is greater than or less than 10. Where did the number 10 come from? I tried to look for that in the reading and could not find it.
I think it's like infinity. It just is. Some really smart mathematician figured it out, and so we now just accept it.
Okay, Mom. I've used that same thing.
True proportion. 5 is true proportion.
Is P hat the sample proportion?
Say that 5 is what?
I got true proportion because it's a 1 to 15.
I agree with you, Macy. What I'm asking is P hat, the P with the little hat guy, is that the sample proportion?
That is.
Mom, should I wear the black shirt or the red shirt with it?
Black.
Okay, and then can I use David's Dr. Seuss hat?
Yes, I think it's in our closet. I will find it in the morning.
Okay, sounds
Okay,
good.
you look cute.
I want to be like a girl Dr. Seuss.
You look
Where's
cute.
this 50 cents?
It's okay.
It says
It's okay.
the estimator of P is the P with a little hat.
The estimator, huh? Okay.
Yeah.
Good enough. So number 6, we know N is still the sample size.
So 5 is the true proportion?
Yeah. If P is a small
So that one's a formula thing. Oops. Need to find my formula.
And V star over squared.
Can you put that up close, Macy?
Yep.
N equals Z squared times, oh, and that has a couple of formulas. Okay. Does that one also, isn't there a formula like N equals Z star divided by 2M? That was in the next lessons.
Oh, I'm in 17. Great. Sorry. That's probably not the right formula for that.
Okay.
How did you get in 17 when you gave the correct answer for number 5?
Well, I was in my 17 notes.
Oh,
She studied.
Right.
She knows her stuff.
you had me worried, Macy.
I know. I worry. I don't. Okay.
So which
Okay.
one are we on? Are we on 7?
We're on 7.
Yeah.
And we're looking for 16. I think it was in the preparation assignment. There we go. There was a formula for that. Huh. You know, there's one that's p hat equals x divided by n. We could solve for, we could factor n out of that.
Yeah, I think there's a formula for that.
I thought there was too. I'm not finding it.
Let's see.
Wonder if we did it in the homework rather than just the.
I'm just looking at it. I don't know. You actually can't listen to FGS.
Good job, Princess.
I know
I had to solve for an n earlier. I'm not finding it.
I thought that was maybe I'm crazy.
It might have been, because I'm not finding it either in the homework or in the individual study on
No.
16.
Go for N. Let's see.
P.
Okay, so let's, oh, Pat. Okay, listen, here's how I say we do this. See that formula up above that's NP is greater than 10? Let's do N is an unknowns, put in 1/4 for P, okay, is greater than or equal to 10. So if we get rid of that by itself, it's going to be N has got to be equal to or greater than 40. And on the other side of the equation, if it's N equals 1 minus P, and we put in P as 1/4, is greater than or equal to 10, and then it's N equals, I'm gonna switch to decimals. Nah, I'll keep that way. Equals 3/4, and we put it over on the other side. It's going to be 40 over 3. So I propose that the answer is 40. Did you guys follow that crazy math at all?
I kind of do.
Yes, I do. So NP is greater than 10, greater than or equal to 10.
Yeah.
And N times 1 minus P.
Yep. So it's, yeah. So here's the answer I'm getting. I'm getting that if it's 40, so then we'll plug it back in. If n is 40 and 1 over 4 is p is greater than or equal to 10, then when you cross cancel, you get 10 is equal to or greater than 10. And on the other one, if you convert that 1/4 to the n minus, so I'm talking about the n times the quantity of 1 minus p. If you make it n times the quantity of 1 minus, and then do 0.25 to make it easy, okay? Then you get n times 0.75 equals 10, and then you divide, then you're going to divide 10 by 0.75, because you move it to the other side. And so that becomes 1.2, 3. I'm doing math the longhand. I shouldn't do this. Waste too much time. Yeah, 1.33. So the smallest that it can be to and it, you know what? It's my turn to go first. So I'm going to put in 10, and if I'm wrong, we'll figure out another answer later.
Okay.
I'll take one for the team.
So you're saying 7 is which one?
I think 7 is 10 because you have to satisfy both of them. You can't satisfy just one.
Okay, so for number 8, the formula is T equals X over N.
Okay.
So,
Okay, for 8, say that again.
T equals X over N.
To get the p hat, right?
Yeah.
Or to get just plain p?
Yeah, I don't do the second big yet. That's what I'm trying to. Wait, that is the second one, yeah.
It's to get
The formula is this.
Oh, hold on. I clicked off your face. Let me come back. Move it just a little bit to the side. Yes, okay, so it's p hat. Okay.
Okay. So, for this one, we have our N, and it's 24, but, and would we use regular P? Would it be 24 over 24? Or where do we get our extra?
Okay.
Let's see. I think I'm going to go to Google and find out.
Okay, so the mean of p hat, this is one of those silly things that the mean, remember the mean is the mean, and it's mean to ask, you know, the mean of the sample mean. The mean of p hat is the same as p. So if you look on the preparation assignment, question number, part 2, number 6. Nope, part number 8, number 9. Sorry, number 9 for real. About the cell phones.
On which one? On the
preparation homework or preparation number 9 is what this one is like that. Only they're just giving us numbers and not. So 9A is what is the mean and the standard deviation. Well, the mean was 7% is P, and up here they're telling us P is 0.4. So the mean of P hat is also 0.4.
Okay.
Boy, I'm not grasping this one tonight.
So remember when we were using the standard deviation and we had X and then they threw in X bar?
Yep.
And the mean of X bar was the same thing as the mean of X. And we kind of made that little automatopoeia or little funny phrase that it was mean to ask what the mean was because it was the same thing. It's the same rule for this P. The mean of P hat is the same as P. So when we read question number 9, it says 7% is P. And then on A, it says, what is the mean? Well, the mean was 7%.
Yes.
That was the answer. So I think it's the same thing, that the mean of P hat is 0.4. The same thing as P.
So number 8 is 0.4.
That's what I think. And it's my turn to be wrong this week, so. Okay, and now we need to do the standard deviation.
Okay, so this is the formula that I have for standard deviation.
Okay, let me look at you here. Oh, hold on, you went away.
P hat is square root of 1 minus P divided by N.
So for this one, we would point P hat is equal to square root of 0.4 1 minus 0.4 divided by 24.
Okay. Okay. Is the wind picking up again outside? I can hear noise outside. Our house has already been hit twice by trees falling on them. We've had 2 trees land on our house, and today we had some big branches hit the house, broke part of the tile roofing, knocked out the.
Tell me what you did. Oh, we did take the skirt. Never mind. We need to do something else. I don't know if this is right.
I got 0.1.
Okay, did you take the square root of it too?
Yeah, because I had 0.01 before. Let me make sure, because it's
Oh, No, you're pretty sure my calculator just continued it instead of. Yep, I got my own too.
Okay.
So it would be 0.100. Right?
That's a good question. Probably.
You have to do that.
Because,
There's 3 decimal places.
hold on, what did that just do? 0.24. I'm just running my calculations again to make sure I didn't make a mistake.
Well, I made the mistake. But
Okay. Oh, just let me know for sure. Okay, yep, I got the same thing again, 0.1.
Okay, I got that one. What I was doing wrong.
Okay.
Oh, crud. What am I doing?
You okay, Rusty?
I'm still trying to figure. I'm trying to do the calculation.
Okay.
So with your formula, Macy, it's 0.4 times, in parentheses, 1 minus 0.4.
Correct. Divided by
24.
Yep.
Let's see. Are you coming up with 0.1?
Yep.
Wow. Okay, that's number 9.
Yep. But remember to give it 3 decimals. Macy was right on that one. So up on number 8, we probably need it to be 0.400, right?
Yeah.
Okay.
And the next one is the exact same.
No. We're going to switch.
Oh, wait.
Because then we get into the Z-score one. Because we have a second. So we have a second factor to add in that she wants to get. Nope. Okay, so let me. I know how to do this one.
My screen share with you. This is my camera here.
Let me find this here.
So see, here on our thing it says, right here, P estimator equals X over N.
Yeah, I don't think it's that one. I think it's this one. Tell me what you think of this one.
So how the heck do we know if which one we're doing? It was the exact same.
So look at this one and see what you think. And I'll explain why I think it's this one. Okay, see this formula?
Yeah.
Okay, because we have a P of 0.300, right? So a 300 batting average is basically 30 hits per 100. And we want to find out if she can get 35. So that becomes the P hat. So we're going to take P hat minus P over this bottom part is that standard deviation formula, right? And that gives us a Z-score. Can you see how later on in the same questions, it's asking for a Z-score?
Okay, I do, but for question 10, I don't understand how we're supposed to get the P hat.
probably right. X over n?
Yeah, it's p hat equals x over n.
Okay, but what's our...
35 over 100.
Oh, you're going to use it that way.
I'm pretty sure.
I like that idea. Because x is like...
To show us we don't have the p estimator, we only have the p. So we have to find it in 10, and then we use it for 11.
I like that because 35 becomes the number, the n, the how many. Okay.
Right.
P hat equals x over n over 100. Okay. I'll go with that. Thanks.
Can you tell me that one again?
So see, this is what your equation will look like here.
Let's see. P hat equals 335
Over 100.
over 100. Okay.
Okay, and that gives us 0.35. So that's our answer for number 10.
350, right? Nope, 2
Yeah,
decimals.
350.
It says 2 decimals.
Okay. And then I think we use that equation that's
Nope, I think we used the one that we just used. The p hat equals the square root of p times the quantity 1 minus p over n, the whole square root of that.
Yeah, I agree. Yeah. Okay.
I'm sorry, what did you say, Tanny?
Okay, hold on. Was that giving us a p hat? The standard deviation. Hold on. I'm confusing myself. Just a minute, Rusty, and I'll answer my question if I know what I'm talking about.
This is what I have for my equation for this right here.
Okay.
I want to see it one more time, please, Macy. I'm sorry. Let's see. Wait. Oh, okay. Okay. So, but Macy, that says that it's for p hat, not for the standard deviation. That's kind of what I'm questioning. But I don't know why I'm questioning it.
Because the actual equation is the standard deviation of p hat.
I see that. Now I've got it.
I just didn't write those words.
Okay.
So the square root of your answer should come up to 0.045.
Let me do it.
And if we're rounding to 2 points, then or to 2 decimal points, then it should be.
And this one does say to 3, Rusty, on the problem.
Okay. Let's see. Which number are you on?
11.
Oh, okay. So it's 0.046.
Yep, that's what I got, Rusty.
Okay, and then so the z-score then is going to be back to that one that I had put up.
Equals p estimator minus p. Yeah. Because we have to find all these things first. What is p, which is 0.3 divided by v, which is 1.3 divided by 100.
So right. So see the bottom of the problem is just what we did to find that 0.4046 or whatever that number was. I'm not on that page right now.
Yes.
Yeah.
So when I got to this part, I just started reusing that answer as the bottom part of the equation.
I agree. So we did 0.05 divided by 0.046,
Yes.
and you got 1.08.
695. So I burned myself doing this earlier by rounding too early. But yes, I agree. So I've been a little bit cautious with rounding. But it says 3 decimals, so I think we round. 0.87. So now we need that applet.
Okay.
Now, are we
Let's see.
doing both ends or coloring just one?
So my opinion is we're shading to the right. Because
Just to
we
the
want
right.
to find out what's the chance that she'll hit more than that, was the question.
So it's 0.136.
13. I have 1.1385.
That's what I had to. I missed the 8 when I was saying it.
Okay. Which is going to round up to
0.139.
Yep. I have too many papers in random order on my scratch pad here. I lost which number I was looking at. Okay.
14. If the chairperson voted to call a political candidate, P equals 0.52 and equals 3,000 people are surveyed, we want to determine the probability the results of the survey will suggest the candidate is losing the election. Getting back to 50% of the voters, what is the standard deviation of P? So we're going to use that same equation.
P times P minus 1 minus P, right?
Correct.
Yeah.
Divided by
and all in the square root. Okay.
the square root of that.
Yeah. Kind of like this class when it's one formula and it's straightforward.
Oh, I know it. Minus 0.52 divided by 2,000 equals.
Okay. I got 0.011.
.011.
Yeah. Any
Right.
takers? So when I take it into the next problem, though, this is where I burned myself. I have made the rule for myself that I take it out 5 decimals. You know, when I told you I substituted it for the bottom, because that's what we're going to do on the next problem. I just kind of looked ahead. So I'm keeping for my denominator 0.01117.
I think that's a good rule of thumb.
And I remember that night we met with, why can't I remember her name now?
Soraya.
Yeah, Soraya. She was saying that she always kept hers out too. Okay, so P.
So you're doing the 0.01171.
Yeah, I stopped at the 7, but yeah.
Okay.
P hat. Do we figure out the P hat on this yet?
Yeah.
Was that the point?
I did my whole equation wrong because I was using that.
So P hat is X over N, right?
Yep.
So X, do we know what the X is? Does that become 0.50?
I don't know.
What is the equation for the Z on this one? I saw it a little bit ago.
It's this. Let's see. I probably need to screen share for you to be able to see that. It's this, but we don't have a P hat value right now. Do you remember any other Z square or Z formula?
Say that again, Tammy.
I think that was the only Z formula. But I'm kind of thinking that we have to use that 50% of the vote somehow.
Okay. Z equals the value minus Z over the standard deviation.
Z equals what?
Value minus the mean over the standard deviation.
But isn't that same formula I showed you?
Yeah, it probably is. This is looking.
I'm opening myself up another tab so I can get into the textbook as well. I think, I could be wrong, but I think we've got to use that less than 50% of the vote. I think that means something to us.
No, I don't think it means something. I just can't remember what it means.
I think if we use it, we have an N, right? Can that become our X? The sample we want is...
Here we go. Here's an example here.
Okay.
I'll share my screen. Okay, so here in the textbook, see what I did that. Okay, here in the textbook, right here, it talks Z equals P estimated minus P, which right here is talking about 50%, somewhere I saw. Right here, 50%
And it
so
says,
we find the probability. Here we find the B similar to it, so it's 5 minus 0.48.
so Macy, it's not super clear on mine, but does that say that the p hat then becomes greater than 0.5? But for us, the p hat becomes less than 0.5. So when we use the z, we're going to go to the left side, right?
Yeah.
Yeah. Okay.
But I think all it is we just use 0.5 for 50%.
Right. I agree. Is the p hat value?
Yeah.
Yep.
Okay.
I like it.
Perfect.
So we're using 0.5 minus, let's see, minus 0.52.
Yes.
So you have p hat minus p times 0.05?
No. I have p hat minus p, so I have 0.50 minus 0.52 all over that equation on the bottom that earlier we figured out was 0.01117.
So did you get 1.79?
0.5?
Yeah.
Yeah.
Okay.
Did you get negative 1.791?
Yes.
Yeah.
Well, there's a fun-looking question.
1.71, right? What probability do you use? You compute. What probability that was?
I'm going to pick the less than one.
So I have 0.036.
What are you figuring that for out there, Rusty?
I plugged in the negative 1.791 into the left side, and that's the only side that I have colored. Does that sound right?
Yeah, that sounds great.
So, Teddy, you're using the smaller one for 16, right?
Yeah, for 16 I chose choice B.
Which is V is less than small v.
Yes. Okay, and then I like Rusty's answer for the next one of 0.0366. Okay, should we review?
So 16 is the second one?
Yes.
All right, I'll read from the top. Are we ready?
I'm ready.
Hold on a second. Hold on a second. Let me...
Okay. We have like 4 or 5 meetings left.
I enjoy you all, but I'm really looking forward to it.
Okay. All right. Number 9 is 0.100. Number 10 is 0.35. Number 11 is 0.046. Number 12 is 1.087. 13 is 0.139. 14 is 0.011. 15 is 1.71.
I have negative for that one.
Yeah, I have negative on that one also.
Probably. Okay, number 15 is negative 1.71. Number
Hold
16
on just a minute. Read 15 again.
Number 15, negative 1.71.
I have negative 1.791.
91. I forgot the 9. Okay, perfect. That's why we redo it.
Does everyone have that answer? Rusty, what did you have for 15?
15, I have negative 1.791.
Ooh, I don't have that. Can anyone? Is that what Macy had before I corrected her?
I was trying to calculate and I didn't hear what the answer was, but I was using p hat minus p, and was there a value in that top before it's divided, or was that it?
So it was p hat minus p, which was 0.50 minus 0.52 for a negative 2, divided by 0.117.
1117?
0.1117.
Okay.
Which is 1.7905, which would make it 1.791.
1.791 negative. Not negative 1.791. That's what I have.
Okay.
Okay. Now I'm not hearing it. Is it negative 1.7991?
Yes.
Yes.
That was what I was reading just a minute ago, I thought.
Okay.
Okay. Number 16 is the big Z is smaller than the small z. So the second one. And then number 17 is 0.0366.
I agree. I'm going to hit submit. Here we go. Wish us luck. 94. We got one wrong. Let's see which one. It's the number 7 for figuring out the n.
I don't know. I mean, I'm okay with.
I don't know how to do it either. And the thing is, you guys, if one of you wants to figure it out, you can hit save for later and come back and work on it later.
And
Knowing that we got number 7 wrong, and I'd encourage you to do it. You know? Hit the save for later button and then come back. Well, you'll have to get to it tonight because it's due tonight. But if you want to fuss with it later.
That's what I'm going to do.
okay.
Okay, on to 17.
Okay, on to 17. Okay, so yeah.
All right, I'm starting 17.
Okay, I need to get that other soft thing downloaded real quick for 17.
The other what?
There's I need to get the link for Excel, the new stuff. There it is. Normal applet to please. Okay, where is that link? Did you get that?
There it is.
There it is, categorical
data analysis.
analysis.
Okay, I don't know where you're at. In the homework?
No, in the reading. So go into the textbook.
Okay.
And it's in section 2.3, using Excel to perform these calculations.
Okay.
See that hyperlink there?
I do.
We need to open it up.
Which is the categorical
And
analysis?
yeah, down at the bottom for Excel.
All right.
Okay, so we'll use that on our homework.
Okay.
Or on our group work.
Okay. So true. Simple for true population portion.
That was the P hat, wasn't it?
Is that what we got in the last one?
Oh wait, P is the true proportion. Number 5 on that last quiz is P. Is P the true proportion or the central proportion? And we got true proportion.
Okay, I'm going to screen share with you guys because I have it here on my book.
Okay.
Just don't. Yeah, come on, screen share option. Maybe. Am I screen sharing right now?
No.
No. Come on. I'm in some really weird. Oh, there we go. Screen share.
Your true proportion is just P.
You found it too?
Yeah. Are you screen sharing?
I should be screen sharing now. So here we go. The true proportion, comma, P, right there, under my mouse, right here.
So
just P.
So it's just P. Thank you.
Yep. Okay. So this one, we have to do that NP greater than or equal to 10 and N times 1 minus P, right? Okay, so I want to show you guys, am I still screen sharing?
Yes?
Okay, so I watched the videos on this.
Say that again.
I watched the videos on this.
Okay.
And it looked like we could go right into here, into this thing, and input the X. And for this one, X is what? I don't have any idea. Is it the 0.25 or is it the 0.10?
I would guess 0.25.
Okay, so we'll just put that in just for fun.
Okay, and the confidence interval for assuming the
So
the null hypothesis.
0.25, and the confidence, do we have a confidence interval?
No, I think so.
Okay. So can you see the hypothesis test requirement right up here?
Yep.
Are both greater than 10? So that it does it for us in this software. So I'm going to put in the 0.10 just to make sure we answer the question right, since I don't know this well enough yet. But they're both greater than 10.
And they still are if we do that.
So I think the answer is yes.
Okay.
So X is what? In that,
I don't know. We have to figure that out. And then the same question for the hypothesis test satisfied? Maybe not. Wait, what's the difference between those two? Confidence interval and then hypothesis test. I'm going to have to look in the book because I don't know the difference between the two.
Confidence interval is finding confidence interval
Oh.
patterns of actors.
We've done this before.
Yes, we start with the calculator and then we add or subtract the number of the deviations of the value. The point estimate is P, or P is half. Well, standard deviation of the right.
I think though still, if we understand it, in the video he was saying we didn't actually have to do the math. We can use, oh, there you go, 2.3, using Excel to perform these calculations. Finding confidence interval for only one proportion using a calculator is tedious. An Excel spreadsheet will help you, blah, blah, blah. Okay. So here we go. Out of this group, 114 admitted to cheating in medical school. So they have their X. We weren't really given our X. Let's read that question again. We don't have an X.
So weird.
Oh, here we go. If we can solve for X,
well, I'm shooting basically the B half over equals X over N. I thought we could solve for it that way.
I like that idea. P hat equals X over N, right?
Yeah. I don't know. Maybe we can solve for it. I don't know.
No, I think you're right. Why can't we? It's just algebra. So we have N equals 100 and P hat equals 0.10. So we're going to times 0.10 times 100.
That's what I got.
So X equals 10? Okay. My calculator looked funny, so.
Well, 0.10 times 100, that's 10.
Yep.
I concur. I did math the old-fashioned way. Rusty's got it exactly right. So we're going to go back into this applet thing then, now that we know what our X is. And we're going to say X is 10 and N. Okay. And so both of these, the hypothesis experiment and the other one, are both equal then or greater than 10.
And what was N?
N is 100. Or, yes.
100. Yeah. Yep.
Okay, so it's the same value that's already in there.
Yeah, I plugged it in. And right here, it does look like that confidence interval is 10 exactly, but it does say greater than or equal to. Hey.
So that's also true?
Yep. Study. Sample of 60 people. So that's 60 is X. Of these, 45 defendants were guilty.
So P hat is 0.740? That's what's in the descriptive statistics in that box on that Excel
sheet.
We're on a different question though, with different values for number 6.
Never mind.
Okay. That's okay. So is our P 45 on this one? So
I would think yes.
So N is obviously 60, right? Because that's the sample size. 45 people were found guilty. So I'm sorry, but why isn't that your X?
X is going to be the 45?
I'm asking, I don't know.
I think so. I think we're going to do 45 over 60.
Okay.
So they give us that for a reason. So I got 0.75.
For P hat?
Yes.
It says 3 decimals, so let's make sure we take it out too.
3750.
Yeah.
That's 45. So I'm going to go on and putting it in the spreadsheet.
To get a 95% confidence interval.
Yeah, and then I also got the second one, 0.640 and 0.860.
Okay, so you used for N, you used the 60. And for X, you used the 45?
I did.
So you got a P hat of 0.750. Do you see that it's on the thing?
Yes.
On that Excel thing? Woohoo!
Oh, yeah, right there. So I think I know how to calculate it. And then...
So the confidence interval would be 0.640 and 0.860?
Yep. Better than the 1%.
Okay, 8. If you increased your sample size from 60 to 80, what
do you expect?
Ah,
It increases.
Did you say decrease?
It increases.
Oh, it increases.
I tried to wait. The P hat decreases. My hypothesis that it increases. Confidence interval is
it just shifted it.
interval decreases.
Why do you think it decreases? Oh, it does. Yep. Yep.
Yeah. 80, it decreases.
Okay.
So 8 is decrease?
Yeah.
Okay, and then this is that same.
Oh, rats. Same kind of an answer. Or question.
What's that?
It's the same kind of question that we had over in that last one.
The next two are the same questions. Alright, so let's go back and try to figure out.
Okay. Well, then we'll at least have it right for you guys.
So which one did we get wrong in that last one?
Number 7.
Okay, so where C is determined, I you guys. Because it might have found something. Right here it says, it does that. Okay. Right here. Okay. It talks about the Z-score. And let's see, determine your confidence level, margin of error. Sample size, he says the two equations can be fairly similar. I don't know if that was anything.
Hold on.
I'm thinking this is what we're supposed to use.
What's the Z, though? That's the confidence. I know what that is. I remember from the video. That's the confidence interval. So,
Okay,
so let me write that formula down.
Bring it back.
Bring it back. N equals Z asterisk thing over 2M divided by 2. And M is the margin of error, right? Yeah.
Yes.
Okay.
Well, M is the margin.
That the Z asterisk thing is called the Z star.
Okay.
And there's not really anything. Like I asked her more, and she's like, just part of the equation. So now we know.
Okay, so the Z, like on our question, it says, do we have the same data? I'm just making sure. Question 6, 7, and 8. No. So my idea doesn't work. Sometimes I know that Z, like if it says a 95% confidence, then you put 95 in affluent and you get that 1.9 whatever it is. But that's not going to work for this one because we don't have a confidence interval or requirement. Sample size. Okay, can you see right there at the sample size calculations?
In the text?
Yes. Under section 3, N equals the Z thing times M. But we don't have any of that. I don't know what to do with that, but there's an N all by itself,
Yeah. Can we get our Z score? Can we figure our Z score out like we did like a couple weeks ago?
You know what I'm going to do? I'm going to pop back to the previous chapter 16 because I think we missed something. I think we have to know how to solve for it. I think if we know how to do it from the week before or the lesson before, we might get it right for this one.
I'll go back here to do it.
If we have a prior estimate for P, we can plug this value into the equation above to compute the sample size required to obtain our desired margin of error. So in all of that we already did, where Z is determined by your confidence level, M. So
Equals value minus mean over standard deviation. We don't have enough information to solve for that, do we?
nope, not yet.
Well, darn kids, I don't have an idea.
I don't either. I don't know how to do this one.
In number 4 in the text, hypotheses test for one proportion.
Is that lesson 16 or lesson 17, Rusty?
17.
Okay.
So and number 9 in our quiz, it says to conduct a hypotheses test for one proportion, 2 requirements must be met. Okay, so if the following conditions are satisfied, and that is NP is either greater than or equal to 10, and N times, in parentheses, 1 minus P is greater than or equal to 10. Those must be the 2 conditions that need to be met.
Okay, so here's my suggestion, guys. This one, I mean, I think we can spin our wheels on it all night, but it's not due till Thursday. So I say we skip 9 and 10, and we all agree that we'll contact Soraya and then maybe send some emails to each other, and let's keep going on.
Okay.
Does that work for you guys? And we'll just hit save for later on this.
Yeah, that's fine.
Okay. So number 11. Questions 11 through 16.
We'll put this into this thing. Everything. That equals 80. So what do we do with that 60%?
Right now, I think we just hold it on that. Because the first question is it satisfied?
And I would say true.
I'm still getting there. X is 36.
38 or
38
36?
or 36.
I'll have to look at that.
38.
38, thank you.
Yeah. Okay.
So they're both, yeah, they're both met, huh?
And that is 475. Oh, computer, don't freeze again. Oh, no. Oh, my computer froze again. I'm gonna have to restart it.
Okay, we'll be here.
Can we use Excel that
Yeah,
that we already have up?
Yes.
Yes. If you have, it tells you right there regarding how you calculate it. 475.
The Z statistic is, if I'm reading this right, is that the negative 4.392?
In the Excel sheet, does that .70 have the null hypotheses? Should that on Excel be marked out of there, or should we be putting something else in there? The null hypotheses is 0.6.
I don't know that.
I think you're right, Rusty. I think it's 0.6. I think that alpha thing of 0.05, the confidence level is 95% to get the 0.5. So I'm going to put in the 0.6. That
Okay.
changes the z-score, and it doesn't change the p-hat. And then you can see then the null hypothesis matches what our question says. Good catch on that, Rusty.
So for 11, what is your answer for that one?
Number 11, I have true. Number 12, I have.
And what makes it true? What figure in here is it that we use that needs to be greater than 10?
So the question is conditions for a hypothesis test. So that's that first, right under the title, it says hypothesis test requirements, both greater than 10. So you have a 48 and a 32, and those are both greater than 10.
Okay. And then p-hat is 0.475?
Correct? And the z-value it gives you on the next line
is negative 2. Let's see, negative 2.282.
Yeah.
All right, come back. Let's see.
And then the p-value is
Really quick.
0.011 for the p-value.
Yeah.
Okay, so what is 11? 11 is 2, 12 is what?
0.475.
Okay, and 13?
Z-value is negative 2.282. P-value 0.011.
Okay. And now am I caught up?
Yep.
Yep.
Okay.
And 15 is reject the null,
That's what I think.
because it's a 0.05.
The P is low, reject the null.
Which of the
16.
following best summarizes the conclusion of this test? There is sufficient evidence to conclude that water quality in the area has decreased. So the hypothesis was, so the
So we're
first
gonna-
one,
Yeah, I think the first one too.
that's what I came up with.
Okay, I agree with that.
Okay,
And
so
then we'll go back to 9 and 10 and then
I propose we hit save for later. Let's review our answers right now so that we all have the same ones for these ones.
Okay,
okay.
1
Okay.
is true, 2 is true, 3 is P, 4 is true, 5 is true, 6 is 0.750, 7 is second choice, 8 decreased, 9 and 10 we're saving for later, 11 true, 12 0.475, 13 sorry, it's not going to come out.
Negative 2.282.
Thank you. 14.011. 15 reject the null. 16 first choice.
Okay, so I'm hitting save for later. So I propose we each work on 9 and 10, research them, and send some text messages and see if we can get an answer before Thursday.
Okay.
I have tomorrow off, so I will work on it diligently.
And are you going to submit the chat for tonight?
I am, but we also have to do our big thing, our final project.
Yes. And has any of you, either one of you, worked on that at all?
I looked at it. I have not worked on it.
Okay.
There's not really a lot to do for this week, but I say, like, even if, I don't know, like next week or something, if we either plan like a different night and just took a full hour and just even if we did all the project, I don't know, that's a good idea.
Well,
But just got it done.
I went ahead and worked on that because I had that up when the power went out, so I could go ahead and work on that a bit.
Oh, perfect.
And so if you click into design the study, it brings up a sheet. I
got lost again. My computer shut off. I'm sorry.
I've got that, Rusty. Can I? Oh, so I can't even screen share. Okay, I see that.
I'm
You're good.
going to try to send it to you by way of mail. What I have. And let's see if I've got it all. And this is just kind of a, I tried to attach the actual document, but it won't, for some reason, won't let me, so I just copied and pasted, and we can all fill it out at a later time. Well, I guess it has to go tonight.
What are we supposed to do for tonight? Like, what do we need to have that?
The design your study is due by Saturday. So I need, if possible, since we're still, have a half hour kind of ish left, I'd like us to get our design the study done.
I
Right?
agree. That way we don't have to worry about it.
Okay, so I just sent it to both of you. To the, I just emailed it.
Did you send it to school mail or to Gmail, Rusty?
Let's see. Yours went to. I sent it through the school mail.
Okay.
Are you MAR 15055?
I think so.
Okay, so it went to your school mail.
Okay, I'm getting it.
And Macy, yours also went to the school email.
I got it. Good deal.
And so the first one I have just our names in there, and the teacher or the instructor that we add Nelson into it, and so one of the choices, and I think we discussed this a couple weeks ago, are the distribution of colors between plain and peanut M&Ms equal. And it says state your research question. And my evil twin got in here and typed in some stuff before I was able to hog-tie him. There was actually a thought of doing a research on the amount of frosting in a double-stuffed Oreo cookie and its counterpart, the original Oreo. There was one interesting situation. The frosting kept disappearing. We suspect the dog or Rusty. The problem was solved with the decision of using the example above, whether the colors of M&Ms are evenly distributed between the plain and peanut option. Of course, there is a monitor to oversee that no M&Ms disappear during the experiment. our research questions will be, are the different colors of plain and peanut M&Ms evenly distributed between both packages of M&Ms? And then it says, what populations are you studying? We will be studying the numbers and percentage of each of the colors present in each bag of M&Ms, both plain and peanut. And I'm not sure if we need to do both numbers and percentages or just numbers. And if you guys have an idea, you can throw it in there.
What populations will you be studying? Our populations, I think, is bags of peanut M&Ms and bags of plain M&Ms. Those are the populations. The numbers are the samples and stuff.
So that number 2, what populations are you studying? What should the answer be for that? Repeat what you said, Tanny.
Yeah. So I think, what are the populations you're studying? Plain M&Ms and peanut M&Ms. Because that's what the population is.
And can you both see my email that I sent?
Yeah, I have it open right now.
So number 3, do I have the null and the alternative hypotheses correct?
Okay, so here's a question I had. I kind of like the ANOVA ones. I thought that they were a little bit easier. Did you guys like ANOVAs or not?
I thought they were okay.
So, and I liked it because the hypotheses were easier, because you could say that they were all equal or that there was a difference of one of them. So if we change the study just a little bit to do plain peanut and peanut butter M&Ms, then we can use the ANOVA.
Yeah, that's a good idea.
Okay.
Okay, so my question is, are we each going to buy a bag of plain peanut and peanut butter?
Well, in order, let's see, in order for it to be, what do they call it? Distributed. Say that again. So you have to have either more than 30.
Oh, yes. I know what you're saying.
So if we were to, we plan to use at least 30 bags of plain M&Ms and 30 bags of peanut M&Ms from a group of whatever.
I can't afford to buy 30 bags of M&Ms.
And
I mean, for real, they're $4 a bag.
Yeah. Well, what if we could fit like a little tiny $5?
No, or hold on. What if we just take 30 M&Ms? The first 30 M&Ms that drop out of a bag. Or we could say our sample size is, does it have to be, do we have to sample the number of bags, or can it just be the number of M&Ms for the 30?
Maybe after we'll design it, we turn it in, we'll like come up with it, and then our instructor will approve it, or just tell us, you know, we need to have so many bags of this, or whatever.
What's your thoughts, Rusty?
can, I was still trying to go with, I'm not,
30 bags at almost $4 a bag is $120 for peanut and $120 for plain. That's a $240 project.
But think of the movies you can watch with them.
Yeah. No. Thank you. I'm not spending $240 on M&Ms.
Okay,
You
so
know what? I don't think it's breakfast too. I think there's a different way to do this experiment. We just our brains aren't thinking of it.
I think it's just 30 M&Ms, period. I think it's just 30 M&Ms. I don't think you have to have 30 bags.
So we just need to have a bag of peanuts, a bag of plain, and a bag of peanut butter, and then you dump 30 from each bag.
Now, I have a question. Why? So we have a bag of plain and a bag of peanuts. How about we dump them all out? I'm thinking the peanut one is going to have less, right?
Yeah.
So if we dump, and let's say we get 50 out of our peanut bag, why can't we just randomly select 50 out of the plain bag?
now say that again.
M&Ms are sold by weight, and peanut M&Ms are going to be heavier than
Yes.
plain ones. So let's say that a bag of peanut M&Ms has 50 M&Ms in it. So that's going to become our sample size. Can we just dump or randomly grab some random ways, not just look at the bag and pick all the green ones, but so that we just get 50 M&Ms out of the other one?
I think there's a way to do that. I think we should do it that way. We should just come up with like a project overview, like we're doing, and submit it to her tonight, and then see.
So I like that idea if we just dump out 50. And because we don't know, we're not dictating what colors are coming out.
Should we just dump out 50?
Correct?
Correct.
Yeah, so I think we word it as we will count how many are in a large bag, or, you know, which bag has the most, and then we'll just put them all in, shake them, and randomly dump them out, so that both samples are the same.
Okay.
Okay, so here's another question. Do they have to be the same sampling size? Can we have more of one than the other?
Or if we're using ANOVA,
They have to
be
be the same size.
I'm pretty sure that they have to be equal.
Okay. Okay.
So, what populations are you studying? Are you studying the number?
Cool, and are you still with your computer? Okay. Well, mine just keeps shutting off, but it's okay. I'll just go with that. It just keeps shutting off.
So, are you doing a real research question? I like your joke one, but are we turning that in?
Say that again.
I like your joke, but I was wondering if we were being a little bit more serious on our real research question.
I thought of that too, and I can go ahead and delete that part.
I think it's funny though.
You can leave it and then just add a little part at the end. I don't know.
So, with number 3 are your null and alternative hypotheses. So I need to have if we're using ANOVA, we need to have a third one.
Yes, I think our research question will be: are the different colors of plain, comma, peanut butter, comma, and peanut M&Ms evenly distributed between all packages of M&Ms?
I think that's good.
Say that again, Kenny.
Are the different colors of plain, comma, peanut butter, comma, and peanut M&Ms evenly distributed between all packages of M&Ms.
Are different colors of plain peanut and peanut butter evenly distributed?
Uh-huh. Between all packages, not between both, but between all. So then, for what population will you be studying? We will be studying plain peanut and peanut butter M&Ms.
Okay. We will be studying just the M&Ms, not numbers, correct?
Right.
Okay. And then the hypotheses?
HO is all. Is it all means are the same? I'm going to pull that up.
My computer no longer time. I'm just going to be done for the night.
No,
And
you
then-
have to stay on the phone call. No running away.
But I
Yeah.
don't know how many more times I can log back in. I can do anything. Oh my gosh.
Sorry, Macy. Okay, so number 4, it says, which sampling method will your group use? And I was thinking systematic sample method, but if we're just going to dump it out, what would that be? If we just dumped out 50, so that would be the random sampling, just dumping them out?
Yeah, because it's not really a student. We're not taking. We're not putting one in and using one. I don't know. I think it's like a random.
So it's a simple random.
Yeah.
Okay, and then number 5, describe in specific detail how your group will collect data using the sampling method stated in the question in step 4. Also, what sample sizes? Go ahead.
Go ahead.
So for the simple sample, what we'll do, the simple random sample, there we go. Just explain how we are going to conduct 50 minutes of each type of M&M.
Okay.
And then we're going to count the colors. There's not going to be any type of system or anything like that. We're not going to count that out and then get rid of one. It's just going to be where it comes out of a. Should we say we found a medium-sized bag?
Yeah, yeah.
Hold on just a second.
So the medium size.
I actually went to the store today. I know it said not to start doing any collecting of data, but I can at least find out if there are 50 in what size of bag. I'll be right back.
Okay. Honey, can you see me on the computer?
Let's see. Can I see you? No.
Okay, my whole screen is black and it won't even shut off now.
Oh.
Like overheated itself. I'm pretty sure my laptop just crashed. We're good.
Oh no, Macy.
Yeah, towards the end of the semester, this is my luck.
Hey, who is the what's the name of the tutor you've been using? Because you are like so on top of this, I could use some more help.
Her name is Anna. Let me see if I can find her last name.
And how did you get hooked up with her?
So I actually, I kind of did it the wrong way, but I went in and I just, asked for a tutor. And then she contacted me. She was like, I'm going to get the BYU Ice Center. I have tutoring appointments all day. So I was like, wait, I'm an online student. And she's like, okay, well, we'll be over straight. So I don't even know. Her first name is Anna. And
Okay.
she's really good.
Yeah, I mean, I'm looking at you today going, oh my goodness, she like has no question. She's in charge, and I'm going, I don't know for sure.
Well, I was just like a bit freaking out.
No, I can. I mean, it really shows. I mean, you understand it,
It's really good.
and I just kind of
I
muddled.
even met with her this week, so
Yeah.
I actually meet with her on Thursday.
Hey, Rusty, is that you in your M&M bag? Okay, can you see my screen? This is right out of the textbook, the hypothesis things.
And what chapter? That was the last chapter?
For the ANOVAs, because we're going to do an ANOVA.
Yep.
HO, all the means are equal.
Okay.
HA, one or more of the means differs from the other.
HO, all of the means are the same.
It says are equal. I don't know if that specifically has to be are equal, but
Are equal.
yeah, are equal.
And then HA is
One or more of the means differs from the others.
okay. I didn't catch that last part.
One or more of the means differs from the others.
Okay.
All right, so what else do we have to fill out on this one?
So if we use simple random sampling, let's see, number 5 is described in detail. Plan to use 50 plain M&Ms. Okay. Number 6 is why do you think the sampling method described in questions in the questions in steps 4 and 5 will give an accurate representation of your population? And
You know what?
what?
I'm
Still stuck on. I'm gonna look at some of those data sets. I don't know that they have to be the same number of things.
Oh, they don't?
I'm asking the question. I don't know.
Okay.
Do you have to have the same number of samples?
Okay.
I'm going to open up one of these data files that we use for the ANOVAs.
Well, in a 1.69 ounce bag of M&Ms, there are at least 50.
1.69. That's a small one. That's like a individual size, right?
So if we got the next size up, we would be sure to have 50 in there, and they would. There might be only 49 in this bag. I think the dog scarfed one of them, or me. And the.
Okay, so if we got the maybe peanut butter and plain, you have enough.
And so the 3.27 ounce package of peanut M&Ms, and it's called the sharing size. There's only 40 in there.
Yeah, we're gonna have to get those bigger bags.
Or we could just drop the number down to 40.
Oh, that's true. Whatever you guys want to do.
So we can go ahead and have Nelson also tell him that he needs to come to the United States and buy a package of peanuts, M&Ms, and peanut butter M&Ms, and plain M&Ms.
I bet that they have them there. Okay,
Okay, I don't have the answer that I'm looking for, so we'll just go with the 30. Or the 40. Okay.
Go with 30 M&Ms from each kind.
Or 40 or
50,
50, whatever number we want.
Let's shoot for 30. We'll shoot for 30.
Okay.
Okay.
I'm sorry,
Okay.
Rachel, but I'm not doing anything right now. It's all right.
It's all right. So, Rusty, I think you're just going to have to type our name because obviously we're not going to sign this, you know?
Correct. And I have your names in there, and I will go ahead and sign your names in the bottom like I will type it. And I'll send it off to her tonight. Does that sound okay?
And I would not put Nelson's signature there.
Okay.
I
I would just, up at the top where it has our names, I would say, you know, I'd put there, wasn't present when things were decided. You know, just so that they can see that we're trying to include him, but when he's not here, we can't.
I've got his name up there, and I'll just add an asterisk to it. Does that sound okay? And she'll understand that.
Yeah, you know, because we don't want to falsify that he agreed to it, but we want to give him the opportunity to do his work as well, you know, and be part of it.
Yep.
I
Okay,
feel bad for him because we're trying, he's trying, but it's just not. So the only time he contacts us is if he wants answers.
yeah.
Okay.
So I'll go ahead and fill this out.
No, I think we have to, the very top, we have to fill out the steps, who's going to do each step. Because then we bring it and we check it out. Check it with each other. So the main writer for the design of the study is Rusty, because Rusty, you did all this already.
Yeah.
Should I take out the first part?
I haven't decided.
I think it's okay to leave it as long as we have a serious statement as well.
I don't think our teacher has much of a sense of humor. So I would, simply for that reason, I think it's very hilarious, and I have many instructors that I've had that I would keep it on, but I wouldn't for her.
Okay.
But let's see if it's funny.
It was really, really funny.
And I laughed, so. And I'm going to show my husband so that he can hear what it is. Okay.
All right, so I will go ahead and put this together and send it off to her.
Hold on. Up at the top, the step 1, 2, 3, 4, 5, 6, 7.
We talked about everything. So.
Your step, Rusty, step 1. Do you see where we are, Rusty?
Yep.
Okay. Who wants to be the main writer for Describe the Data?
I'll do that.
Okay. So I guess I'm number 4. Make the imprint.
Yep.
Okay, and then I'll do take action, and I'll put Nelson in there with the asterisk next to it.
Okay.
Let's get Nelson too. So let's let him do like a 3 and 5 or something like that. We can't do 2 just like we do. Like we're gonna have 2 different meetings.
Okay.
Okay, and then number 6, I think that we can all kind of work on it together. I can kind of like polish it and put the main stuff in there if you want me to.
So it's
if you guys just help me like decide what we need on the PowerPoint, I can make the PowerPoint and make it look good and stuff like that.
good. So why don't you put, so that everyone's name is down there twice, why don't you put mine and Macy's for the PowerPoint?
Okay, you want all 4 of us in that one?
We could do all 4.
Let's just put, because we know Nelson's not going to help us do the PowerPoint. Let's just try Rustini on the number 6.
Okay.
And then he can do like 3 and 5 or something like that, if everyone's okay with that.
I'm okay with that. Rusty, do you feel like you've been given too much? Because you definitely have 2 full sections.
You know, we've got 4 more weeks to do all of this. I think it should be fine.
And you know, the other thing is like, for step 6, if you guys could just tell me this information, I can do the whole PowerPoint myself. If you can tell me this information, and I can like put it into different slides and transition it and make it look presentable and stuff like that.
Perfect.
Okay, so down here, state your research question. The example of whether the colors of M&Ms are evenly distributed between the plain and peanuts and peanut butter options.
Yep.
Our research question would be, are the different colors of plain and peanut butter M&Ms evenly distributed between both packages, or all 3 packages of M&Ms?
Yep.
Okay, and then number 2, what populations are you studying? And you said what, Tanny?
All 3 of them, so like the plain, the peanut, and the peanut butter M&Ms.
Okay, and then the hypotheses and the alternative, got that. And which sampling method will your group use? And we'll do the simple random sampling. And then in number 5, describe in detail how your group will collect data.
So that one, here's what I think we need to do, and I could be wrong, okay? But I think we've got to buy a bigger size bag of M&Ms, okay?
Yep.
Because I think we've got to have the medium size bag so that we stick our hand in and pull out 30 M&Ms. Because then it's simple random sampling. Where if we only have, and I happen to be enough of a connoisseur to know that the peanut butter ones aren't always available in the share size. So I think we get the medium size bag and then we pull out 30 random samples. Plus then we can repeat it by sticking them all back in the bag, shaking it up, and doing it again. You know what I mean? And then that's our sampling method, is that we're going to take a medium-sized bag of M&Ms. We're going to put our hand in and blindly pull out 30 M&Ms.
Okay.
And why do we think this sampling method will do it? Because it's going to fulfill the law of large numbers so that our sample will be evenly distributed. Wait, the ANOVA one had different requirements, though. Hold on.
Yeah, it's not the same.
Let me look real quick. Let's see, week 7, right? Several means. It had different requirements. What were they? This is requirements. Data normally distributed and the variances are equal. So that's right, that the largest variance is less than or equal to 4 times the smaller variance. So we'll have to say in there that we'll check for variance
the law of, or the theorem still applies in this one, though, doesn't it?
So we're going to say, so I think we'll just say that it's normally distributed because of the central limit theorem. Yep.
Okay. All right, I will get that up and running.
Okay, and I will post this tonight, and I will also work on numbers 9 and 10 and send some text messages. I won't guarantee they're right, but I'll do my best to figure it out.
Okay.
And if you guys have a chance to figure it out, work on it too, and send your answers.
Okay, I meet with my tutor on Thursday, so
Perfect.
maybe she can help me out, and then I can tell you guys.
That's great, because I think it's due Thursday by midnight. So,
Yep.
okay.
Thank you.
Thank you.
So Rusty, you'll submit the design the study tonight for our group, and we only have to submit one copy, right?
Yep. I think it's just one copy.
Alright.
Okay.
Rusty, when you get it,
Thank you so much.
when you
Good night.
submit it, will you, Rusty,
Yes?
when you submit it, will you CC us what you submit as well?
Okay.
Or email it to us, the final one?
All right.
Perfect, thank you.
You're welcome.
Alrighty, guys.
Good night.
Good night.
Thank you.
Thank you.
Bye.
Bye-bye.
Bye.